Welcome back to another video on one sample t-test. So in the usual procedure we would go for the definition of one sample t-test, and I would show some assumptions, and then I will show the formula, and then we do the SPSS. But I think it's a bit boring doing those stuff, so I think I will change that procedure, and we will look upon into a story, and I will describe when and how we will use the one sample t-test, so it can be a bit more interesting. So welcome back to this video on one sample t-test. So if you didn't hit the subscribe button, please subscribe so you can see more videos that will be uploaded by me. So let's begin. So here we can see a very cute little bee. I will call her as Boo. My dear Boo, so cute. So let's begin. So our dearest Boo need a home, a beehive to live in, and it's her dream to live in a beehive. And so she decided to buy a home for her, and she was thinking, where should I buy a home? Where should I should need some peace. So she was thinking, and finally she decided to get a home near a mountain place, and also a beautiful nature place of all animals and very beautiful rainbow stuff. So she decided to visit the queen, our boss. Let's her name was boss, the badass boss. So here comes our Boo coming to visit our boss, and she's just saying that I need a home, boss. I need a home to just reside beside you in this beautiful mountains. Now our strict badass boss is saying that, yeah, I will give you a home. There are plenty of homes in my neighborhood. You can buy anyone, but there is some cost associated with it. So the Boo asks, how much? What is the cost? Now our boss is saying that you have to get me on an average of 5 liters of honey to get one of the house for you. So 5 liters of honey, it's so big. So how can our Boo can afford it? Even though if she afford it, she want to know whether is it worth it to give 5 liters of honey, or this boss is cheating me or not. So we can't know, or she didn't know, the Boo don't know. So what does the Boo done is that she has gone to each of the neighborhood of that home, and she asked them, she just called them ting tong, and when each of the bees comes out, she would ask them how much you gave for this pretty home, how much liters of honey you have gave to the boss. So they have given some of the input, some of the data, and those are these. Some said they have given 6 liters of honey for one single room, and some said they have given 3 liters, just 3 liters, nothing more. But here the problem is that the time is there, it is also involved, so it's in a back end time was in. So maybe this 3 liters was cost back 10 years back, and now 6 liters was cost back 2 years back, some due to some situations or environmental disasters, the prices ranged up. So Boo has this data, and Boo need to analyze this data. So she decided which test she have to use. We have a one group, or let's say there is only one single group of data, and it's all in continuous format, and I have a hypothesis population mean of 5 liter. I have to check whether these data could sum up on an average of 5 liter. So here my hypothesis, my null hypothesis will be our sample data will be equal to 5 liters. That is our the population data, the population mean, that is our mu, will be equal to 5 liters, and is true. What does the Boo said was true, that is 5 liters is the cost of one home. So here she have to use our t-test. So here x bar means our sample mean, mu naught means 5 liter, that is our population mean, s is the standard deviation, and n is the sample size. But our boo don't know how to calculate this, so she need a help from a professor who is expert in SPSS. So she visit a professor who is an expert in SPSS, and she is asking for help. Can you solve this? Can you solve this hypothesis testing? So our professor says, yes, sure, I will do it in the SPSS and give you the result right now. So let's start in the SPSS. Alright, now our professor comes to the SPSS software, and he creates the data. So the data is in the continuous format, so he gave the scale and the measure, and here is my data, and he is confident that we have to use one sample t-test, because you can see, first of all, our data is in continuous format. Second, we have to analyze these to a hypothesized mean, that is, we have a population mean, and we are checking that this sample mean, this sample can show that it is exactly on an average is same to the population mean. So here we have 5 liters as a means, and so I am checking whether, so these data on an average will be same as 5 liters on an average. So on we can do for like analyze, and here you have compare means, and we have one sample t-test. In one sample t-test you have to give the test variable. So here in my case is honey, and my test value will be 5 because my population mean is 5. So I'm just checking that. In options you can give, if you need 95 percentage, you can give 95. If you need 99, you can give for 99. Okay, and then you can click on OK. So here we have our output. So this is a small descriptive, and here we have our test. So you can see this is my p-value, sig to tail. This is my t-value. Degrees of freedom is 13, that is n minus 1 is the degrees of freedom. 14 observations were there, therefore 14 minus 1 is equal to 13. And this is the confidence interval, and here we have our p-value. So this is a two-tailed p-value. So here it is 0.098, which means not statistically significant, greater than 0.05. So we will say, or we will reject the alternative hypothesis, and we say that there is no enough evidence to reject null hypothesis. So we can say on an average, in our B case, in our B case, whatever it is, so on an average for each on an average for each house, on an average it will be around 5 liters. So it said on an average, not exactly 5 liters is needed for each house, so it may differ like that. We saw that there are 3 point also 6 were there. So it depends upon, first of all, many other factors such as time and how spacious your building should be. So different factors are there which are associated with that. So we will say on an average, so most of the houses will be costing around 5 liters, but it can reduce, and but it can increase too. So if you need a luxurious house, it will increase to 6 or 7, whatever it is. So if you don't need such luxury, you just need a simple home, it can cost low to 3 also. So on an average, so we say on an average it costs around 5 liters, and our p-value is not statistically significant, so we have to accept the null hypothesis and say yes, it's true. So that is our Boo case. So Boo either have to give 5 liters on an average, maybe it can differ, and have a home or not on those mountains. So that's all for teachers. I hope you have understood it very well. So if you need more examples, you can always search on Google. so there's no necessity for me to provide more examples because it's always available on the Google. So you just type examples for one sample test, you get the real case examples. This is same as costing of a house in London or costing of a house in USA, New York, somewhere place. So we check, we will say on an average it will cost around, if we rent a house in London, let's say about $1,000 on an average, but it can differ. It can differ, and but on an average for two-bedroom room, it may cost around 1,000. So this is the real case scenario on which we use the one sample t-test. Thank you very much.